This is Zach Goliarnik, CS275L4. This assignment was a lot more involved than the rest of them, so I'll try to be a little bit briefer as I'm going through the fine points. Here you can see my activity main.xml. It is a simple app view with one list view on top of it. The more complicated one is what I've called list row.xml. This contains an image view and 4 text views to be populated into each item of the activity main XML's list view. Then we have the custom adapter.java file, which dictates how the list row.xml is used to populate activity main.xml. We have an array with all of the necessary information being passed in, and the text views are updated accordingly. You can see a couple of global variables there. This is all auto-generated code. Then we get down to here, which is, as I just explained, the text views are all updated with the text that's being passed in. However, the image view must be updated in an asynchronous task because only the image's URL was passed in by the function, so another network call is needed. This is why the images often take longer to load, which we'll see when I run the app. So we've got the asynchronous task here for the image down here. The adapter's main structure came from the link to GitHub that was provided on the lab page, and the image generation code came from Stack Overflow, also a link that was provided to us. Okay, weather.java is a class that I created myself with attributes corresponding to the data we were asked to pull down. Here you can see I've dimensioned it all and then set it all in the constructor. The main part of this class is the overloaded getForecast function. The first version that you can see right here takes in the JSON array from the weather website and the database to which we want to cache the results. So you can see it's using the same JSON parsing code as we had the very first time we did this. We clear the database before we do that, and then we rebuild it down here. This line here is necessary because we only want the first row to get the system time, because otherwise I was running into a problem where some of them were being updated so quickly that they had the same system time, and the database was complaining that there weren't unique rows being added. So the first one I plug in the time using this current time in milliseconds function. For the rest of them, I just plug in the value of I, which is my counter. The second version of this overloaded function takes in the 2D array filled with data read out of the database. No changes are made to the database in this version because we don't want the time to be updated and then screw up the rest of it. So I'm just populating out of the database this hours array. Both of them return the array, which is sent to the custom array adapter that I just showed you. The database manager.java file maintains the database. Each piece of data that is requested is stored in a new column, including one for the retrieval timestamp. I originally wanted to store the entire JSON file, but I had a lot of trouble trying to convert that to string and back, so it ended up just being better to do it this way. However, that came with the cost of needing to overload the other functions. Most of this code came straight out of the book, but I provided a custom remove all and check database for existence functions. So all of this code that you can see here came out of the book, but check for existence was mine coming sourced from Stack Overflow, and this down here, the remove all cleared it for debugging purposes. Most importantly, however, the retrieve rows function, or retrieve data, I guess, that I wrote was entirely revamped from what was listed in the book. I needed it to return a 2D array where each relevant piece of data had been parsed to a different index. So as you can see here, for each time, date, condition, temperature, humidity, and URL, I'm plugging those into a different index of my array, and then using the cursor move to move on and do that for all of them. Okay, so in main activity.java, what we've got going on is all of our imports at the top normally, a couple of global variables that help solve some scope problems I was running into, and then we start. On launch, it checks to see if the database exists. If it does, and the latest retrieval time is within the hour, data is read from the cache. This code here does the check to see if the database exists, and if it does, we open it, retrieve the data, close it when we're done, and then evaluate the times. You can see I'm doing current time minus last time divided by the conversion to hours. So if the difference is within an hour, we want to put up the toast, which it said just display a message to say that you're doing this, and then go down here to populate. I will show you that in a minute because that was actually overloaded as well. Otherwise, whether the database doesn't exist or if it's been over an hour, it makes the network call to the weather website. This is done in an asynchronous task, which I'll show you at the bottom, but I also want to point out here that I did the extra credit. The Android's GPS feature is used to get the current location to make this call. So that's what's going on here, the location manager. If the location is not null, then set the latitude and longitude, and then make the call to the async task. This code here under the else is, as I explained, the exact same, repeated in case the database does not exist at all. So, scrolling down here, we have the asynchronous task that makes the call. This is the exact same code from the week 1 lab, except for now we're using the latitude and longitude rather than just putting the city in as a string. If this is successful, we get out this time array object, which is the JSON array with the hourly forecast in it, and then in the on-post execute of this asynchronous task, we call populate with time array. Now you notice before I called populate without passing in any arguments. So here you can see that I had to overload that as well. The first version takes the JSON array and calls the weather function, the version of that was overloaded to take in the array and the database. So this would be the version that updates the database. This populate without any arguments is the one that came from the cache. So there, all that does is it doesn't take in anything, but it sends the 2D array table content in to be processed there. After the processing is done, however, the rest of the code is the same. The array that it gets back with everything parsed nicely gets sent off to the adapter, and I already showed you that, so we're good. Okay, I'm going to run my code now, but before I do, I'm going to come up here. It has not been an hour since the last time I ran this, but to show you what would happen if it had, I'm just going to change that to a greater than sign, and I'm going to run it, save my changes. It'll come up here. Now, it'll come up with a blank screen, which is because on the emulator, it doesn't have any coordinates. So I need to go into here to open perspective, other, run my DDMS. This, I assume, would not happen if we were using an actual phone because the coordinates update would be instantaneous. I'm going to put in the coordinates that I found for my hometown of Pittsburgh because they're having a little bit more interesting weather than I am right now. Longitude is -80, latitude is 40, and send. So now I'm going to get data here, and as you can see, for some reason you need to scroll around, give it a little time to update the pictures, but you can see that as you're scrolling, we're getting the time, the condition, the temperature, and the humidity, all of which were asked for, and the different pictures corresponding to each of those things. So that's very good. I'm going to move back to my home screen so that I can come back to here, close this view, and now I'm going to change this back again so that it does look like it's within the hour. I'm going to rerun it so that it gets uploaded again. And this time when it comes up, you should see the toast saying reading weather from cache, and it will still update. Now, it looks like it doesn't take significantly shorter time, but that would be the idea of running it from the cache instead, is so that it takes a little bit less time. Again, the pictures were a little slow to generate, but everything looks good. And actually, I think the clock just clicked over. It's 10:03 now, so it's a different picture up at the top than it was the last time. But everything is still in order. The scrolling list view looks good. And I just have a couple of closing remarks. It was very involved to do all of this. I solved all of the environment issues with the last lab, but everything from the custom layout to the pictures, the GPS, and especially the database required a lot of time and effort. I'd say my time spent was upwards of 15 hours, including 1 with my professor in office hours and 2 in the CLC. I learned quite a bit, of course, but it was just a lot for a weekly lab. Running the GPS on an emulator is a bit screwy, and overloading the functions to support both the JSON and the database cache may not have been the best way to go about it, I admit. There are also a lot of global variables all over my program, but most of the functions already passed in a couple of things without further complicating them. What I will say is that having a fully functional app that I can take around with me would be worth the time and effort, if I had a phone that this would work on, I guess. Okay, so once again, this was Zach Oliarnik. I partnered with Dana Thompson for this lab, and our names and emails can be found in the README, along with a pretty good rendition of my script for this assignment. Okay, all of the files can be found in the directory I'm uploading to Bitbucket, including the APK, which my understanding is everything can be run directly from. But all of the source files will be there, and including this screencast demonstrating that it does work, at least on the emulator. Thank you.